Real quickly, I want to amplify what's in the book about the graph of the logarithm function and just relate it to generalities about graphing inverse functions. We start, let's say the base is 2. It's going to be very similar with different bases. We start with the graph y equals 2 to the x, and that has an asymptote here, goes through 0, 1, goes through 1, 2, and then swoops upward like that. And then the point is that this is the same statement as x equals log 2 of y. In other words, they're inverse functions. Stripping off this and solving for x involves a logarithm. So since it's an inverse function, what we do first is we actually go ahead and switch the x's and y's, switching inputs and outputs to get the graph in the right way. So we say 2 to the y equals x, and that's the same as y equals log 2x. Okay, and so that the graph of the log is this inverse process from the flipped version of this equation. So what does that mean? We go back to our general understanding of inverse functions. Not a bad time to go back to an earlier video I did about generalities of inverse functions, and then we applied it to sine and cosine. Now we're applying to the exponential function. So the slogan is you just take this graph and you flip it across the y equals x line. And that's pretty good here, but I want to remind you of a little bit of a different method. Let's take a couple of explicit points, which we know, flip those carefully, and then look at some verbal description of what's going on. So 0, 1 gets flipped to 1, 0. 1, 2 gets flipped to 2, 1. So the log of 1 to any base is 0. Log to any base of 1 is always 0, because b to the 0 is always 1, no matter what the base is. And log base b of b, that's always 1, because b to the 1 is equal to b. Okay, so it goes through those 2 points. And now, what's going on here? It's going up and to the right, which gets translated to right and up. Okay, sort of sounds like the same thing. Now it's getting steeper. In other words, more towards vertical. And remember, the translation here is anything to do with vertical gets flipped with horizontal. So steeper gets translated into less steep. So it keeps going like this, but gets less and less steep. Does it approach an asymptote? No. This just gets very, very, very big very fast. So this gets big slowly, but it doesn't ever reach an asymptote. There's no upper limit. Then this guy comes this way. And then here, this goes way, way left. Okay, that gets translated to down. So left, that's big negative x. That gets translated to big negative y, or down. And it's got a horizontal asymptote. Aha, so this is a vertical asymptote. This asymptote was at y equals 0. So this, you just switch x with y, and so this is x equals 0. So there's that asymptote. And so that's the graph of log base 2 of x. All basic logarithm functions go through 1, 0, because they all satisfy this. And they just have somewhat different shapes depending on the base. But they all have these same features of getting big slowly out here, going through 1, 0, and having the asymptote.